All right, well, welcome everybody. Good morning or good afternoon, depending on where you guys are logging in from. We're going to go ahead and get started here. Hopefully my audio is good. Everybody on here should be muted, but there will be a chance at the end here for Q&A. There's a chat window as well, and so I'll go through those questions and anything that you put in there, and then we can go through those on the webinar here. My name is Nick Harper with ATG. I'm our Director of Reality Capture here, so that covers everything in the scanning world, from the LiDAR side of things to the drone side of things. So before we get started though, I did want to let everybody know, it's a chance to catch up here. We have a new user group series starting up here. And typically our user groups are on location in various cities, but we have a new series here starting that is going to be online, and this starts tomorrow, September 4th. And we can send out the link to this as well. But this discussion is going to be around a scanning project, the Charity Hospital in New Orleans. Big deal about this here is this is over a million square feet and 9,753 scans all run through recap. So quite the project, quite the feat of all the technology that was used. You're going to be hearing from various experts here at ATG on that and be able to discuss that just like one of our normal user groups there. And again, we'll be able to send out a link to the registration for that as well with the recording of this webinar here today. But today, what we're going to be talking about, again, so this is about full reality capture. And so we're going to be looking at basically taking LiDAR data and then drone-based photogrammetry, and then ultimately combining that data. Typically, people tend to use one of these technologies or the other. They just use the laser scanning to cover the site or the interior of the facility. Or they just fly the site, use the photogrammetry and get their topography that way, or just get imagery. These two different pieces of technology don't have to be kind of mutually exclusive in that space. Yeah, there's better reasons to use one or the other depending on the project, but ultimately you can use these two tools together and actually combine that data. And that's what we're going to be looking at today. So just a little bit of information on the hardware and software side as far as what we're going to be going through, what was used on this particular set of data that we're going to be looking at today. On the hardware side, we're looking at the Leica BLK 360, very compact scanner. We'll look at some of the specs of that as well. And then on the drone side, pretty much off the shelf, something everybody's probably very familiar with, not really high end as far as the economical side of things, but the Phantom 4 Pro. And then on the software side, we're going to be going through Autodesk Recap Pro. Both the mobile and the desktop version were in use in this particular project. Autodesk InfraWorks, AutoCAD Civil 3D for the site side of things. We'll take a brief look at the data inside of Revit. And then on the drone side of things, 3DR's site scan product. So again, on the hardware side of things, what we did the laser scanning with is the Leica BLK 360. Not going to go into a ton of detail on this hardware here, just illustrating basically how compact this unit is. And you can see there on that screen capture there's one button on this device, but captures 360,000 points a second and does a full scan in 3 minutes. So you can cover a lot of ground really fast, capture a lot of data. And then again, on the drone side of things here, just something everybody's probably familiar with is the Phantom 4 Pro. The biggest thing about this to take note of is when we're talking about UAS and photogrammetry is the image sensor. This has a 1-inch sensor, so it is a very large sensor compared to A lot of drone hardware up there. And then as far as the actual resolution, this is a 20 megapixel camera. But again, that image sensor size, that large image sensor is what allows you to capture just the fine detail that you're going to see here. So I'm going to pop out of this PowerPoint here, and we'll take a look at some of the actual data that we've collected. And we're going to start out with the actual scan data here. So let me bring this over on the screen here. So I am inside of Autodesk Recap Pro. This is the desktop version of that. Recap, if you're not familiar, this is the point cloud software on the Autodesk workflow side of things. This allows you to ingest all of your different point cloud formats, do some basic measurement, visualization, and cleanup of this point cloud data. So what we can see here is a site and building that was scanned with the Leica BLK. And if we take a look here, right now we're looking at intensity information, but we can see the actual RGB color values as well. So inside a recap here, what we can look at is, of course, we have the point cloud itself, which we see here, but the scanner is also taking 360-degree photos as it scans. And inside a recap, we can actually go to those scan locations. This allows us to navigate the site visually from that scan location. And here you can see these photospheres where the scanner was placed. And I can just jump from one to the next here. And then when I'm also inside of this view, right now I'm looking at the photo, but I can switch this over to the point cloud data as well from that exact location. So this particular site here was comprised of 63 scans, both interior and exterior. And again, we can navigate through that information here really quick. I'm going to restrict what we're looking at here, and we can see a cross-section into the interior of the building. And we'll let that kind of catch up here. And then we can connect inside of here as well. Select inside here. And again, we're inside of the photo area. And then I can bring up the point cloud data in here, take measurements, all that good stuff. So we have our terrestrial LiDAR scan. So this is great. This covers the interior. We did get a lot of site information, but what you can see here, if I reset this information here, is I don't have any rooftop data. Here, here we can see the rafters of the building. But if there's anything on the roof, we don't have that data. So depending on what the building may be, we might need that information, take measurements where HVAC units are, different equipment that's on the roof. It might not be convenient or safe to get up there with the scanner to do that. So in this case, our option is to also put the drone up there, spend 10 minutes flying the site and capturing the rest of this data. So we'll pop back over to recap here in just a second. I'm going to show you what was done on the drone side of things. And we'll give that screen share there a second to catch up. I know there's a little bit of a lag there. There we go. Should be up. Okay, so what we're looking at here is SiteScan. And SiteScan is a photogrammetry processing web portal by 3DR, where we can take the photos from our drone, upload those. In this case, it was 111 photos. And I'll turn those on really quick, and we can see the location here and pull up the details of one of these photos here so we can see what was flown. Now, all of this information, we can pull up that high resolution information there. Again, we'll give that a second to catch up. You can see great detail with that particular image sensor there. Now this data, again, this was captured in less than 10 minutes for this particular site. And then this information that we're going to look at here was processed in less than an hour, from uploading the photos to getting the information back. So I'm sure everybody is very familiar with what we can capture with the drone. But if we take a look here, now we can see that high resolution ortho from those stitched together images. We can look at any other information inside of Skype Scan here. For instance, some elevation ranges. We can simply turn on contours that are generated from that information as well. And then ultimately we can also, whoops, looks like a problem there. Ultimately we can also view the point cloud inside of the software as well, but you can see there's a processing issue with that. But we have that data downloaded. All this information, we're gonna drop right into Recap and then ultimately just into our Autodesk suite there. So what I've done is downloaded the LAS-based point cloud from this, which in this case, you can see it's actually still processing, but I already have that downloaded. So we can go back over to Recap. And again, we'll let that pop up on the screen there. Now you should be seeing Recap. So again, we're looking at the LiDAR-based point cloud here. And what we can do is we can simply take this LAS file right here, and we can just drag and drop that into Recap. So I have an LAS file that is from the drone, and I have a project in Recap that's already been created, and I can just drag this LAS file into here, and it's going to allow me to combine these scans. And so I'm going to say I want to import the file. And now it's going to go through processing that LAS file that I just added. So we'll give that 10 seconds here. Now that point cloud from the drone was not very large. It was a few hundred megabytes. So not a large point cloud by any means. As soon as that's done processing there, down on the right, you're going to see resume registration. Now, inside of Recap, depending on if you have just Recap or if you have Recap Pro, you can choose automatic registration, in which case it looks at all the scans and tries to combine them automatically, or you can do manual registration, at which point you can pick common points and it will stitch that information together. Now, if you have a LiDAR-based scan and you have used targets to actually georeference that information properly, and then you have done the same thing with your aerial scan, the automatic registration works very effectively in automatically hooking those two scans together. Now, however, if your LiDAR scan is maybe it's an interior of a building and there's just a few exterior scans to tie everything together, and it's just a local coordinate system at that point, then your drone is based on GPS. You might need to use the manual registration where you can tell it, hey, my LiDAR scan is in nowhere in particular, but I want to now combine this with my GPS-based aerial scan. So if I go to resume registration down here, you can see that we have 62 scans and 1 unregistered scan. The 1 unregistered scan is the aerial-based scan. So I'm just going to say resume registration. I'm not going to do auto register scan because that does take a few minutes for that to do. So I'm going to say resume registration, and this is what you would go through if you had to manually register. It is really easy. Recap just works by using photo-based data. So I can pick a point on a photo, pick a point on one of the scans, and not actually a particular point, the exact point, but just literally a horizontal or vertical plane in the same vicinity as the other scan. So we'll give that a second to come up here. And what we're going to see is over on the left, you can see the list of all the terrestrial-based scans. And over on the right-hand side of the screen, you're going to see the aerial-based point cloud come up. Hopefully that didn't take too long. And only because we're all waiting, it's going to take a minute here. And I'll give this just a few more seconds and I'll pop over to one that's a little further along here. But again, what this will allow me to do is I could select from the individual LiDAR scans on the left. See, I could pick a vertical wall out on the site on the left from one of the scans, and then the point cloud from the drone on the right, I could pick that same face. And I would do that between 3 different points, basically 3 different horizontal and vertical planes, and then it would be able to align that information. So this looks like it's going to hang up there. Sometimes we have issues when we're in the Zoom meeting there. So I'm going to go ahead and kill that really quick and just bring up the next step. Just a second. Okay. Let's go grab. All right. So bring up recap again here. Now, this one I've already gone through picking those 3 points. Once this comes up here. But at first, what you're going to see is, looks just like what we were just looking at. So we have, we'll give that a second to catch up here. But you can see our LiDAR-based scan. You can see our roof information is missing. We can see through the rafters there on that portion of the roof. You can see the other buildings here that are completely missing rooftop information as well. Again, we'll give that a second to catch up there. Now I've already added this information, so now I'm just going to go turn on that aerial-based scan. Oh. There we go. It should be coming up. Now you can see we have a lot more information on the site here, and you can see the roofs have filled in. We have a lot more site information around our particular property, offering you some more context to that. But you can see now, once where we had just the interior and site-based scans, now you can see the information is being combined. You can see a little bit on this wall here where there's a little bit of different colorization between those 2 scans, but you can see how those are blended right together there. Now we can see the roof on top, we can see our AC units, the building, the adjacent building here, that information as well. And now we can see our roof information has all been added there as well. Now, I can still navigate the LiDAR-based scans independently if I go down to one of these photospheres here. Here again, we're going to get that photo information that's going to come up from that particular location. And we can take a look at the building. Now, though, if I go to the 3D view, which turns on our point cloud, you can see again, it's the combination, and you can see where those kind of mesh together with a different color tone. But you can see we're looking at the point cloud data from both the aerial and the terrestrial LiDAR-based scans. So we've successfully combined that data. And again, there is an auto registration process, which is great if both items are located properly. Otherwise, that manual process is going to be the way to go. So from here, though, I'm going to pop out a recap here. And I don't need to save that information. And we want to take this information either into our site design software, so our civil software, so Civil 3D, or we want to bring it into Revit for building modeling. Once that information is inside of Recap, that's going to flow into any of those pieces of software. Now, on the civil side of things, people often have to deal with, creating the actual topography from the drone information or from the LiDAR information. It's really heavy data inside of Civil 3D. You create Civil 3D surfaces that are very large and very cumbersome and slow things down quite a bit. There is kind of a critical piece of that workflow, although you can bring a point cloud directly into Civil 3D and generate a surface from there. That is utilizing some old technology on the Autodesk side of things that was kind of wedged into AutoCAD. The point cloud technology the newer point cloud technology is being developed inside of Autodesk InfraWorks. InfraWorks, which I'll bring up here really quick, is a visualization and preliminary design tool in the Autodesk, in the AEC collection there. But what that's going to allow us to do, and I'll bring that one over on the screen here. InfraWorks is going to allow us to ingest that point cloud data and create our surface model inside of there, and it produces a more accurate and lighter weight terrain model than Civil 3D would by itself. So, for instance here, I'm going to create a new model here really quick. And we'll just say webinar. Of course, if you have any additional questions about InfraWorks, feel free to ask, and we can give you more information on that. But basically, what I have is a big blank world here, and what I'm going to do is I'm going to just bring in the point cloud. I'm going to drag and drop the recap file inside of InfraWorks here, and let's go make sure I grab the right one here. All right. And we'll just set a flat long coordinate system for this really quick. All right, so this brought in my point cloud data inside of InfraWorks here, right? Now what we can do inside of here is we have tools for creating point cloud terrain. And let's see if that's come up on your screen there. Yes, it has. So go to point cloud terrain, and I can choose some options as far as how it filters out data. So it's filtering out vertical features, vegetation, things of that nature, and tries to create an actual digital terrain model by filtering that information. So I can hit start processing here. That probably take a few minutes to do that. I'm not going to let you sit there and stare at the screen while I do that. But what I'm going to do is I'm going to go over to one that I've already created here, the exact same site. Let that open up there. Now, our point cloud here has also generated a terrain model that you're looking at here. So you can see we have points that are just floating up in the air. We can see there's a bus stop there, that information, but there's no terrain that's been generated up to the roof of that or anything. So it's gone through and it's done its best at stripping out that information inside of InfraWorks. Now you can always go through inside of Recap and do a bunch of cleanup yourself, which will definitely aid this process. But InfraWorks does a pretty good job with these options here. You can go in and customize how it actually filters things out for ground points, linear features, and vertical features. If you go into customization here, you can go in here and dial this in really well, depending on what your site has going on. So once we've actually gone through and spent a few minutes and generated this terrain data inside of here, lastly, we can go ahead and bounce over to Civil 3D. We'll give that just a moment to come up. And bring that over to the correct screen here. And so I have a blank drawing at this point. I'm going to save. And inside of Civil 3D, we can go to this InfraWorks tab. And this is where we can actually just import or attach that model directly to Civil 3D. And it'll go through, it will convert that data into the relevant Civil 3D objects. In this case, just the surface model. So I'm going to go up here to Open Model. And I'm going to browse out to that guy, the InfraWorks folder, and we'll grab our InfraWorks model here. Now, because InfraWorks, everything is coordinate system based, I do need to make sure that I select a coordinate system for my drawing. And I'm going to do this over on the other screen here really quick. I'm going to set this for the proper coordinate system. And as soon as I do that, it's going to allow me to import this. So I'm going to say Open Model. And we'll let that come in. Now we have the terrain model that's been generated from a combination of the drone information and the LiDAR, terrestrial LiDAR based information. And this is a Civil 3D surface, just like that. And to give you an idea, if I would have processed this data directly inside of Civil 3D, let's say I just brought the recap file in here and we can do it as an example. But if we take a look at the drawing size of this right now, we go to drawing properties, we can see with the surface in here, this is 5 megabytes. Not big at all. But if I were to create a new drawing really quick, and this time I'm just going to bring the recap file directly into Civil 3D instead of running it through InfraWorks. So I'm going to drop this guy in here. Now we have, here's that point cloud information. If I select that, I have an option of creating a surface from a point cloud, which I'm going to do. And I'm just going to hit Create Surface. Now this is going to run in the background here. We'll give that just a couple minutes there. But again, this one that's already been created from running that all through InfraWorks there ended up with a 5 megabyte drawing, very manageable. Now we'll pop back over to drawing 2 here. Should be pretty close. And this is going to take longer to generate this surface information in here as well. But typically, the difference between processing that inside of Civil 3D versus InfraWorks, you can end up with a file that is anywhere from a fifth the InfraWorks, a fifth the direct into Civil 3D size, or even just 10% the size. So it's a huge difference, and the data is actually better. So let that keep going there. That's probably gonna churn away for a few minutes. And then unfortunately, it's just gonna give us worse data. So now lastly, while that's going there, of course, we can bring this information into Revit as well. So again, we have that combined data of our site data from the terrestrial LiDAR and the aerial data. Revit, of course, we can bring that point cloud data into as well, and we can do our modeling inside of there. So I'm going to bring up Revit while this is going in the background. Now, as far as the Revit modeling side of things, there is no magic as far as doing modeling in here. You know, you do have to manually create walls, roofs, those kind of things from your point cloud data. But again, we can bring that point cloud in here, we can create cross sections, and then ultimately create our model from that. So I'm going to go to Insert and go to Point Cloud and go ahead and grab our building here. And we'll give that a second. And here we can see our point cloud information inside of Revit here. And we'll do it. Now, ultimately, what you can end up with on the Revit side here, just one second, is got a version change here. We got just a few minutes left here. But this will show you in progress modeling from the point cloud data here. So there's our point cloud data, and then ultimately to get into our Revit model, interior and exterior based on the scans. This has yet to add the roof information here, but we could turn on the point cloud information and overlay that as well. Or again, view the cross sections of the point cloud to help assist us in drafting this information on there. Let's pop back over to Civil 3D, see if that even managed to finish yet. And again, yeah, so that is still creating the surface in the background, which is, this is not a very large site, just a couple acres here. So definitely recommend going through InfoWorks for that. So if this happens to finish up while we're done talking, we'll take a look at what that size ended up as. Otherwise, we're coming up on time here for questions. So we've run through the LiDAR data, the aerial data, what we can do with that, combining that data, and then pushing that through our different pieces of software here. So there is a chat button inside of Zoom there. So feel free to pop in there and ask any questions, and we'll be on here until nobody has any more questions. And then before we sign off, once again, my name is Nick Harper. You can see my email contact information up there. If you would like to email me directly with any questions as well, any more detailed information. But thank you guys for attending this morning. Those of you who use Central Time, thanks for attending during your lunch hour too. So there was a question just as a kind of a repeat of combining that data. So we had the BLK based scans that were already registered. And then we have the LAS file, which was from the drone data. So I'll pop back over there. I'm going to go ahead and close Revit here. And we'll go ahead and I'm going to open up the recap file. Hopefully it gets to the registration problem or part here. Sometimes during the Zoom meeting, that can affect the operation of recap here. So I'm going to go to resume registration. Oops, on the wrong screen there. Yeah, Matthew, it still says just preparing registration. So we'll give that a second here. But remember, that is, once you have your registered scans, you can just drag and drop that LAS file into recap. And let me see if I can grab the original data, because this one is still trying to register from before. Let me do something really quick here. Just 1 moment. While I'm doing that, though, anybody else have any other questions besides Matthew there? And if it's easier, feel free to also just send me a message and I can unmute you if it makes more sense for you to talk it out versus typing everything in the window there. And actually, it looks like to just answer Matt's question there, I was just wondering how that LAS file comes in. And that is just a drag and drop process. Now, that being said, there is an import button that you can use, but again, it's just as easy to drag and drop that information. So we can import information if we go up to the menu inside of recap. There is an import button where I can just browse out to the LAS file, or again, I've just chosen to grab that LAS file and drag and drop it into here. It's going to bring up the same import window, and I'll say import files. We'll see if we get a little further this time in the demonstration. So it's processing that. Give that just a moment, just about done, and we'll hit resume registration, and we should get that side-by-side window. Hopefully it lets us get through it this time. Usually that only takes, with something this size, might take 30 seconds at the most. But again, it could just be the, there we go. Okay, so it's brought up the registration, so you can see all the BLK scans on the left. Now we can see our drone-based information over on the right-hand side here. So here's all of our aerial, and then here's our terrestrial data. So I could go to a particular scan location on the left, one that made most sense that I could see the most information from. And let's see what I have over here on the left. So what I could do is, again, I'm just looking for common planes between this information. So for instance, over on the right-hand side here, I could pick the face of this building. And then over on the left-hand side, I would simply pick the same face of the building, roughly in the same area. It's just looking to identify these same planes. Now, again, now over on the left, out in the parking lot, I could pick another plane here, pick that in the parking lot, and then I would just need to pick a third location. So I could do the wall of this shed, and then the same thing here, the wall of the shed here. Now this says there's a poor match found. Now I picked 3 points all within a very small area. What I would want to do is over in the BLK scans is pick from multiple locations across the site, not just refine to this area. With the sake of time, I was hoping I could pick 3 points right there. If I hit merge scan, it's definitely not going to work very well. So I do need to pick 3 points across that site though. We'll see what it says here though. Any other questions, anybody? Ron, I see you out there. You have any questions? All right, now because that was a poor match there, it's probably not going to get through that as well. But yeah, you pick points across the site, spread those out, pull that information together. The question is, will the recording be available? Yes, recording will be available. I do believe, Sean, correct me if I'm wrong, but I do believe everybody that registered should get a follow-up link to the recording. I'll let you know here in just another second. And again, on that user group that was mentioned at the beginning, we'll send out a direct link to that as well. So we have the user group, and now this is coming up tomorrow. And there is a link that we can send directly to you for that as well. I'm going to stay on here for a few more minutes if you have any questions. All right, everybody. Well, thank you again for your time today. One last time, there is my contact information on the screen if you have any follow-up questions. Otherwise, I'm going to go ahead and log off, and everybody enjoy the rest of your Tuesday. Thanks.